We're going to finish up our chapter with 1.3 part 2. So for a warm-up, I want us to make a histogram of the 2019 Chicago Cubs salary and then describe the data. So to get our histogram, we're using our calculator. We don't have to do it by hand. I have to sketch it on there by hand. Make sure, a little ahead of myself there, that under the stat button you hit edit and that you have the data somewhere. I have it in L2. You can have L1, L3, it doesn't matter, as long as you know where it is. Then, second, y equals, we're going to turn plot on. Plot 1's already on. And then histogram, so we choose the third thing that looks exactly like a histogram. Make sure your X-list is wherever your Cubs data is. You hit second stat, and you can find whatever list you need to put in there. Right, so I think our plot looks fine. We got the shape that we want, or the graph we want, our data, frequencies just, excuse me, happen once. Now we graph. A little hard to read, so zoom, stat. Still kind of iffy on reading, so let's go to the window. There's no y-axis, so it doesn't matter. Let our x-min be 0, max be 30. The highest value is 27.5, so it's in there somewhere. And let's make this a little bit nicer and go by 5s. That looks a lot better. Now, if you hit the trace button, that first class is from 0 to 5. That's what it says here, and there's 18 in there. 5 to 10, 10 to 15, nobody in the 15 to 20, which is fine. 20 to 25, and then 25 to 30. And we have one value in there. So we just have to sketch that. It doesn't have to be perfect. But we do need a computer that works. We do need labels. So give or take, this is what it should look like. 2019 salary for Chicago Cubs. Got to say what you're talking about, your title. On the left, we have the frequency. Could have done relative frequency. It looked the same. Doesn't really matter. And then the salary is on the x-axis by 5s. That's our histogram. Now, that being said, let's describe our set. Describe the data. Now, I can't really argue here. This is a skewed right graph. Know what two ways about it. The 2019 Chicago Cubs salaries are skewed right, meaning most of our data is on the left, we have the higher values on the right. Now, since we're talking about a skewed right graph, for the measure of center, we're going to use the IQR. Or sorry, we're going to use the median. So if we want to find our median, go back to our calculator and hit stat and go to calc. We're looking at one variable statistics. Make sure your list is the right list there, frequency list. You don't have to worry about that. Calculate it. So we have our x bar, our mean, which doesn't really mean a whole lot because we're not using that. What we want to see are 5-number summary, 0.55, 0.64975, 4.2, 10.25, and 27.5. Our IQR is Q3, or 10.5, or 25, minus Q1, 0.64975. When we subtract those, we get a IQR of 9.60025. In context, what does that mean? 9,600,250 is the median salary for the Cubs. So let's type this up. Our skewed right with a center of median at, where did we say our median was? At 4.2. Or let's put this into context. Get this down here. So 4,200,000 with the spread of IQR 9,600,250. Again, because it's skewed, we're using median and IQR instead of mean and standard deviation. So one last thing we have to do is look at, are there any possible outliers? Now here, looking at these two, there are some possible outliers. There's only three values within there. And again, we're not looking right at the real data, but we may have outliers at the 27.5 range. Don't think that we're looking at, that's not what I want. Sorry, we got to go back to where I have all the data, which is not here either. I will have to find out where it is. All right. So we have 27.5. We have 20 million for Yu Darvish, 20 million for Cole Hamels, 20 million for Hayward. So 20 million, maybe an outlier. 27.5 million, maybe an outlier as well. But when you're talking about our outliers, if the number appears 3 times like the 20 million, it's probably not an outlier. We have outliers at 27.5. Change that back into millions. Again, suppose we can put our dollar sign with it. IQR is 1 and 27 million. Kind of hope that's an outlier, because if not, baseball players get paid way too much money, which they do anyways. But we talked about socks, shape, outliers, center, spread. Notice I labeled the center and the spread which ones we were actually using. We were using median and IQR. All right, 1.3. Box plot graphical representation of the 5-number summary. There is no y-axis. Let's remember what our 5-number summary is. It is, let's see, 0.555, 0.6975, 4.2, 10.25, 27. We have our 5-number summary, and basically you just graph those. We want to start at 0. We can go up to 30. So halfway is 15, 20, 25, 10, 5. So I'll make my number line. 30 mark, 25, 20, 15, 10, 5, and 0. When we plot the first numbers, they're obviously going to be very close together. Because even between 0 and 5 million, we have a bunch of numbers in here. We have the first 3 numbers of our 5-number summary in there. So really pretty close to 0 is going to be our whisker. Then it goes out a little bit, but and then it starts again. And then we're drawing a box to 10.25. And our median is about at 4.2. Then 10.25, we have that, and then all the way up to 27.5. Now again, I wouldn't just do this by hand, although we just did. I would, first of all, use the calculator and try and see if these values are the right values. Now, I think we talked about it. When we are doing our histogram, then go to second stat plot. Oops, second stat plot. Go back to 1, we'll just change it. Make sure it's on. And then we're going to look at this fourth box plot because it has the outliers separate, if there were any. We hit graph. Apparently I did not click on the box plot, thought I did. Now when we graph, again, my data is in L2. All right, pretty easy to see. It's the same numbers as a histogram basically, so that's why it fits here. And we do have an outlier. That 27.5 million is an actual outlier. So what do we do with that? Well, we take the next highest value, 20, and that's where our whisker is going to go to. So we have to take that off for a second and just draw it to 20 instead. And again, 2019 Chicago Cubs salaries. And those dollars in mail. And there's our box plot. I have a better one, a little bit neater. Right here. I don't have any number line that place there. So I have what I need here as well. And you can see, we zoom in between Q1, our minimum and Q1, there's a little bit of a space. So we have to try and represent that, and that's what I tried to do with that. Nope, it just keeps disappearing. All right. So this is how we make our histograms and box plots. Oops, that's not what it's supposed to look like. You just have a line going out to it. So between each number in the 5-number summary is approximately 25% of the data. They are quartiles, meaning, oops, quarters. So it splits it up into quarters. I'm using both things here. So there's 25% between 0.55 and 0.64975, 25% 6.4975 and 4.2, between 4.2, 10.25, and 10.25 and 27.5. So looking at this, I'm going to rewrite these numbers so I can see them for the problem below. I'll get the 7 there. 4.2, 10.25, and so how much data is between 55 and 64,900? And so we kind of rounded there. It's just between these first two, so it's only 25%. Between 64.9 and 27.5, well, we have 1, 2, 3 quarters, 25%. Between 10.25 and 27.5 is just 1 quarter, 5%. Between 4.2 million and 10.25, we have 25%. And between 555 and 27.5, we have 100% of our data. If we want to throw in another one here, which I'm going to, be between 649,880 and 0.25. This is the IQR, but the percentage in between there is 50%, and that's what you're always going to see for the IQR. It's 50% of our data, the middle 50%. So we know there's an outlier in this set. Let's show it with actual numbers and some rules. So outliers are extreme values that are too far away from the rest of the data, whether that's high or low. Outliers are numbers outside of our fences or our boundaries. How we find those upper and lower fence? Over here. Q3 plus 1.5 times the IQR, and Q1 minus 1.5 times IQR. So Q3 was 10.25 plus 1.5, and that's just the rule. Just 1.5 times away, that's what they use. So there's no, it's always going to be 1.5. Then our IQR is actually 9.6025. Again, I put that in millions, so it's just easier to work with. So 24.65 million. Is there a number greater than that? Yes. Let's see, 27 million is an outlier because it's greater than that. Now on the low side, Q1 is at 0.6498 or 75. Oops. Now minus 1.5 times 9.60025. And when we calculate that, we get negative 13.75 million. I don't believe there are anybody playing for the Cubs that is less than negative $13 million being paid this year, where they're taking $13 million from them. So, $27 million, just makes me sad, is outlier for 2019 Chicago Cubs salaries. But yeah, there is an outlier. We proved it. We can see it on the histogram when we make that, but we can also calculate it by our 1.5 rule here. All right, moving on. Just to wrap this chapter up, I just put this picture here so you can see the relationship between a histogram and a box plot on the same graph. It's the same width, give or take. Starts at our minimum, goes to our maximum. Now, when we made the histogram, they were too wide, so even though 15's in there, it's not actually the last value. You can see that the mode is around here, so it's 5. Towards the beginning, and we have our graph. Nothing fantastic here. Now we need to match each histogram to the box plot that represents the same data. So right off the bat, number 1, I have 3, maybe even more outliers. Which one looks like its outliers? Probably letter B, because we have those higher values there. None of them are much different. If we look down at C, the first 2 have a lot of numbers, but they're still pretty close to the 10. So 1, we're going to go with B. 2 is symmetrical. Well, which one of these graphs is symmetrical? D. And it is basically our normal distribution. It looks very normal. Could be a little bit lower here, maybe higher here, but it's pretty normal. Number 3, we have most of the data on the right side, but some lower values. So that is our skewed left, letter. So of course that means C is number 4, which is kind of right skewed, and it kind of showing that, but more of the values are to the right of 2, and that's what we got going on there. And again, symmetrical, we are talking about our normal graph. Skewed right, skewed left, all that are up there, and we wrote those as well. Last thing again, just to reiterate, when we do compare a set or explain what a set is or describe a set, if it is symmetrical or normal, we use the mean and standard deviation. Use a calculator to get it, no big deal. If we're doing median IQR, or if we have left or right skewed, we want median or IQR. That's IQR, again, just a reminder, Q3 minus Q1. It's kind of like range, but a little bit more sophisticated version of range. And that's what we're looking to do in this chapter. Actually, there's one last thing I will show you. I don't know if I showed it anywhere else. Finding these 5-number summaries. So stat, go to calculate, one variable stats. List is L2, frequency list I don't have to worry about. Calculate. Finds our mean of 6.566. Our standard deviation is 6.9. But what we're really looking for here is our 5-number summary. 0.55, 0.64975, 4.2, 10.25, and 27.5. So everything can be done on your calculator, just got to write it down on the paper, of course.